So there are three main methods that we're going to be using, called the square root method, we're going to be using factoring, and then we're going to use the quadratic formula. Before we get started, I want to make sure you guys are familiar with some really important vocabulary. So there are a couple different ways to ask you to solve something. So obviously you guys know what the word solve means, but there could be other ways of asking this. So the results of solving, so if I ask you to solve, I could ask you to find solutions. I could ask you to find zeros. I could ask you to find roots. Or I can ask you to find x-intercept. All of these mean the same thing. So if I don't just straight up say solve this or find the solutions, which I'm sure you guys are really familiar with that kind of vocabulary, you still need to be able to recognize that if I ask for zeros, it means the same thing as solve. If I ask for roots, it means you need to solve. If I ask for x-intercepts, that means you guys need to solve or just look at the graph to find those x-intercepts. So all of these are all interlinked together. So I could use one of these. You need to know that any one of those words means or is the same thing as all the others. Okay, so make sure you're familiar with that vocabulary. The first type of method we're going to talk about is the square root method. We actually did this already at the very end of the complex numbers lesson. You guys remember we did solving with the imaginary numbers? It was brief, but we did introduce it. We're bringing it back here. So this should look somewhat familiar because we have talked about it. I have two different scenarios. I have this one where it's a little bit simpler. There are no parentheses. And then I have this one where there are parentheses. Okay? So when you guys have a single variable, it looks like this. You can have stuff multiplied or added on to that, but there are not going to be any parentheses. You guys need to isolate the squared variable. That means that whatever variable is being squared, everything that's around it needs to be on the other side of the equation. It's just like with absolute value. You need whatever it is that you're going to be solving for isolated by itself. So if you need to add something or divide something, anything like that needs to be taken care of first. Then once the variable is by itself, then you're going to take the square root of both sides. And just remember to include the plus or minus. And then if it's a square root that you can simplify, always make sure that you simplify it before you're done. Alright, so in and of itself, it's a very simple process. So what would I do for this first example? Divide by 3. I'm here. Is the x squared by itself now? Yes, so that was the whole point of getting rid of the 3 is that we needed x squared by itself. Once x squared is by itself, how do you get rid of the square so we just have x? Square root. I'm going to take the square root of both sides. The square and the square root being inverses cancel each other, so I'll do just x. And then what do I have on the other side? Plus or minus the square root of 3. Now, can I simplify the square root of 3? No, but that's your answer. That's it. It's just using the square root to get your answer from a squared expression. Alright, what about this one? You're going to have to subtract. So I would get negative 25. Is the x squared by itself now? Then what? So this becomes x equals the square root of plus or minus the square root of negative 25. Can the square root of negative 25 be simplified? Yes, let's take those flashbacks to the previous part of our unit. Are you allowed to have negatives inside of square roots? No, what do you do to fix that? It's an I, so the negative turns into an I outside of the radical, so it would look like this then. But do I know what the square root of 25 is? It's 5. So our final answer would be x is equal to plus or minus 5i. So you can't forget imaginary numbers. They will be returning. We are going to be seeing imaginary numbers as part of solutions, but remember, it's really simple to simplify it. When you guys see the negative, turn it into an I and then simplify your radical like you're used to doing. So it really shouldn't be that big of a deal. Just remember that that negative does turn into an I. Alright, what about this next one? Okay, so I noticed that there are 2 parts here that I need to get rid of, 3 and then negative 16. Make sure you guys know the order that you need to take care of those when you guys are solving. You have to add the 16 first and then divide by 3. You have to make sure it's in that order. So if I subtract the 16, that would be 48. And then 16. Okay, so then I get it down to x squared equals 16. X equals plus or minus 4. If you just say 4, you would be incorrect. You must have the plus or minus in front. It is both positive 4 and negative 4. All right, everybody okay with that kind of foundational version? You should already know how to do this. I'm sure you've been solving like that enough. All right, so the next type is when you guys still have something squared, but the thing that's squared is inside of parentheses. We're going to do the same kind of thing. You need to make sure that this is by itself. You need to isolate the squared binomial. So anything that's outside of the parentheses, whether it's added or subtracted or divided or multiplied, you need to get those on the other side of the equal sign first. Then once you have your parenthetical expression by itself, you guys are still going to take the square root, but then you have one extra step that we didn't have here. Once you get rid of the square root and the parentheses drop, you're going to have to move this value that's in there over to the other side. So you guys remember when we talked about complex numbers on the same lesson as the imaginary numbers? The one where you have the number and then plus or minus the imaginary? Remember there's specific order, the imaginary number should be at the end? Remember that? So that's going to come in, we've done these already at the end of the imaginary number lesson. That's going to happen here. So make sure that you guys have the imaginary number, if there is an imaginary number, at the end instead of the front. So let's see what happens here. So I have x minus 4 squared equals 15. Is there anything I need to move? No. The parenthetical expression is already by itself. So what do? Again, if you guys are trying to solve, I know we had this before, I can't remember what lesson, but a lot of you guys, when you saw the parentheses squared, you were thinking really hard to not do this, right? You can't distribute. So a lot of you guys are foiling. You don't FOIL to solve. Never FOIL to solve. You use FOIL to simplify something. But if you guys are solving, you want to get rid of the square root. Make sure you put it. So when I take the square root, I get x minus 4. You guys can get rid of the parentheses at the same time you get rid of the square. The board is going crazy. If I scoot up, maybe it'll work better. Okay, so take the square root, don't forget the plus or minus there. So what is the square root of 16? Okay, so I have x minus 4 equals plus or minus 1. Now, do you guys see any imaginary numbers? Yeah. So in this situation, you guys need to be really careful. There are two ways you can do this. I honestly don't know which is better than the other. I'm going to show you both, and you guys can tell me which one you think is better. So the first way that you can do this is to take this equation, because it's equal to both positive and negative 4. You guys can write the equation twice. Like this. Because that plus or minus represents positive 4, it also represents negative 4. So you're basically saying that x minus 4 is equal to two different numbers. So you can write it as two different equations, and then solve them separately to get x equals 8 and x equals 0. Like this. That's how you're doing it before. The other way to do it is just to move this 4 over so you get x is equal to 4 plus or minus 4, and then do the work in your head. Like do 4 plus 4 is 4 minus 4. Just instead of writing it out. So it's just whatever you guys want to do. Both of those things, the blue and the green, mean the same thing. It's just whether you want to break it up visually so you can see it more clearly, or if you just move this over and then in your head you 4 plus 4 is 4 minus 4, and you get your two answers. You get your same answers either way. So whichever one makes more sense to you that you'd like to do as your process, take that and just go. Okay? So that's our first one. If they are like terms, right, it's really important that you notice that these are both like terms, that's why I can add them together. But if this was like for I, anything with a variable added onto it is not like terms of something that doesn't have a variable, so you would not be able to combine them. That's why we came up with the idea of complex numbers. Alright, let's try the next one. What would I do for example number 2? 5 by 3. And then take the square root. When you take the square root, you can go ahead and drop the parentheses as well. And here. Don't forget the plus or minus. Now what? Okay, so what is that square root? 3. Okay, so now I'm here right now. Is this number right here, the 4, that I'm going to need to move over, is it like terms with the 3, the square root of 3? Yes, they're both like terms, there are no extra variables. They're both integers. So I can combine them. So again, pick which method you like to do. You can either write this separately. You can say that it's equal to positive 3 and negative 3, which is the definition of what this is saying. Or you can do x equals negative 4 plus or minus 3. Just write it like that and then do it in your head mentally. Either way, what two numbers do you get as your solution? Negative 1 and what? Negative 7. Yes, it does look very similar to absolute value. You're correct. I mean, it's not exactly the same because this is not an absolute value problem, but it works the same way. You'll get your answers like that. Yep. Well, I tried to fix that so it was more negative and that's that. Any questions about that second one? We'll move on to our last one here. Alright, let's see. What would I do for this next one? Subtract the 30. Make sure that whatever in parentheses is by itself. So subtract the 30, that gives me a negative 36 on the other side. Now that the parentheses squared is by itself, what would I do next? Square root. So when I take the square root, that's going to make the parentheses and the square drop. And what's going to be on the other side over here? Plus or minus the square root of negative 36. Which would be 6i. So notice that little negative there means for the imaginary. So x minus 4 is equal to plus or minus 6i. The negative turns into an I, and then the square root of 36 is 6. Now, are these like terms? No. What's the difference between this problem and the ones over here where they were like terms? Right. This one has an imaginary number. So this is imaginary, this is not imaginary, this is a real number. Imaginary numbers and real numbers are not like terms. So you can't just say that when you add 4, that becomes 10i. That's not how that works. It's just like if you have 2 plus 2x, you wouldn't say that's 4x, would you? No, because they're not like terms. The same thing with I. So this is where we're going to have our complex numbers. This is what we saw in the complex, or the imaginary numbers lesson. So I'm going to have x is equal to 4 plus or minus 6i. If you recall, you still have to add the 4 over, but remember we take this expression and scoot it over a little bit, so we can put the 4 at the front, the plus or minus in the middle, and then the imaginary number is always at the end. Okay? So this one, your answer would look like this, because they're not like terms. If they are like terms, you just have 2 individual numbers, but if it's imaginary, you have to keep it like this, so it looks like a complex number. Make sure you know the difference between what your answer will look like, depending on when you have imaginary numbers and when you don't. Okay, so that's review. We did that a little bit before at the end of the imaginary numbers lesson. Does anybody have any questions about that? If you have a square root of a negative number, it turns into an imaginary number, and then you just scoot this over here and your final answer looks like that. Yeah, you don't have to do these separate little equations because you can't actually combine these. They're not like terms. Any questions about that before we move on? The second type of solving you guys need to be familiar with is factoring. It's just taking what we've talked about the past 2 lessons, the factoring, which I said is really important because we see it over and over again. Next time we see it, we're just going to factor our expression. So once you guys finish factoring, based on stuff that we've done before, you're going to take each factor, what's in the parentheses, you're going to set them equal to 0 and solve. So you're boiling down this more complicated expression into 2 simpler ones that you can solve in your head like that. So it makes it really easy to do. The only thing that you have to make sure is that you write the expression in standard form. You guys can't factor. These are all going to be trinomials, by the way, unless we have our perfect square factoring. You have to make sure it's in standard form, which I didn't write for you, so I'll go ahead and write here. It needs to look like one of these 2 things. You need to have the x squared first, then you need to have the x, then you need to have the number, and you should always set it equal to 0. So it needs to look like one of these 2 things before you can solve. It needs to be in standard form. So x squared followed by the x followed by the number, or if you don't have an x, it would just be x squared followed by the number, or if you don't have the number but you do have the x's, just make sure it's in this order regardless of which pieces you're missing. You'll see different types that they need to be in this order. Okay? So like for this first one right here, is this written in the correct order? No. The x squared is misplaced. Where should the x squared be? Right here in front. How do I fix this? I can't factor this as it is right now. How do I fix it? Nope. What operation would get me to move it over? Subtraction. So if I subtract the x squared, then it becomes negative x squared minus 4x plus 12 equals 0. Now, is this in standard form set equal to 0? Yes, it is. So make sure that you've written it appropriately like this before you actually start factoring. Alright, so now let's just pretend that we're not solving for now. Let's just pretend that I solved this and asked you to factor it. What would I do? The negative is front, the negative is the GCF. So I need to go ahead and pull that out of my expression. That's going to change all the signs. Like this. Now, first and last. Okay. Alright, so if I multiply the first and last numbers, what do I get? Alright, now what's the middle number? Negative 12 and 4. Okay, so what two numbers multiply to get negative 12 but add to get 4? Positive 6, negative 6. Okay, so what do I do with those two numbers? You're going to take those two numbers, you're going to rewrite the middle term using those two numbers, and then you're going to split down the middle. Okay? Then what? Find the greatest common factor for each half. So for the first two, this first half, what's the GCF on the left side? X, so X, and X plus 6, what's the GCF on the right? Negative 2. Remember what's cool about this method is that when you guys are doing this, you can stop and check right now to make sure you've done it right. If I pull out the negative 2, what do I have in the parentheses? The same thing as the parentheses of the other one, so that's how I know that I did it correctly. If you guys had accidentally pulled out just 2, you would have had negative x minus 6 to just match. You can go back and fix your mistake. Alright, so then what do I do? Finish factoring. And x plus 7. Right. Now, I won't be super picky if you guys don't forget the GCF at the front unless it's a variable. So if your GCF is just a number and you forget to write it, I'm not going to be too picky. Because the GCF at the front, anything that doesn't have an x with it is not going to help you solve. So if this is just like negative 1 or negative 2 or whatever it is, you don't necessarily have to write that in order to get the solution correct because it doesn't have an x with it. So once you guys have finished factoring, this is where we would have stopped on the previous lesson with factoring. But when you guys are solving, you just have one extra step. You're going to take each thing that has an x with it, so the x plus 2, sorry, x minus 2, and the x plus 6, and you're going to set them equal to 0. This is the one extra step, because I want to know what x is equal to. So whatever your factors are that has an x in it, you're going to set them equal to 0 and solve. So what are the two x values that I would get? 2 and that's how you factor by solving. Or sorry, that's how you solve by factoring. Yes?
Actually, last episode we solved that.
No, only if the GCF has an X in it. So you'll see an example in a little bit where if your GCF is an X, if you're pulling out an X as a GCF, if that has an X, a variable involved, that would actually be part of one of your solutions. But when you're pulling out just a random number, this is like 2, it doesn't have an X, you can't say 2. Right, it doesn't have a variable. So there's a GCF at the front, you don't really need it. I mean, I want you to get in the habit of writing it, just because if I ask you to factor, I want to make sure you don't leave that off. So it's a good habit to write it, but it's not needed in order to solve, is what I'm saying. All right, what do you guys think about the next one over here on the right? It's already in standard form. Again, that's something you guys need to check before you start. If you have the x squared and then the x and the number, it's all tidy and organized. You guys are good to go. You're golden. So then just go straight to factoring. How would I factor this? Multiply the first and the last number together. So that would be 30. And then the middle number is negative 17. So I need two numbers that multiply to get positive 30, add to get negative 17. Yeah, negative 15 and negative 2. Everybody agree? Okay, what do I do with those two numbers? Right, you take the middle number and you're going to split it apart into those two numbers that we just found. And rewrite 6x squared minus 15x minus 2x plus 5 equals 0. These two numbers, you stick an x on them and then write them in space. Right, then I'm going to split it down the middle. So what would the GCF on the left-hand side? Okay, so 3x. And then if I divide that away, what's left behind? Everybody agree with the left side? Okay. What about on the right side? Just a negative. There's nothing else you can divide away except for the negative that's at the front. So I'm going to write negative 1, just to make it a little bit more concrete. And then when you pull out a negative, what happens? Everything changes sign. So again, right here, you can stop and check. Did I do everything correctly? Did I pull out the GCFs correctly? Do the parenthetical expressions match? You can do a quick check here. So once you've confirmed that everything is accurate, what do you do? Alright, so if I'd asked you to factor, that's where you would stop, but I'm asking you to solve. So what extra step do you take in order to solve? Take each one of these, and you're going to set them equal to 0. So it is possible to get fractions, or decimals, as your answer. So if I do this one, what do I get for x? 1 over 3, or whatever that is in the decimal. And then this one. Which is 5 divided by 2. So they give me the decimal rounded to at least 2 decimal points, or give me the fraction, and that will be half. Questions so far? Yes. So this is, once you have these two mini equations, you would just add 1 and divide by 3, add 5 and divide by 2. It's just linear algebra that you would do for those little equations. All right, let's do our last two. So these are examples of trinomial factoring. These bottom two are some examples of binomials. If you guys see things only in 2 terms. So take a look at this one really quick. Is this in standard form given the pieces that I have? Yes, as long as you have the x squared first and then the x. If you don't have the number, that's okay. It's still in standard form as long as it's in that order. So then, for this one, what would I do? How would I factor that? No. Okay, so completely different. I don't know how you feel that. But yeah, you guys would look for a GCF. Doesn't matter what type of factoring, that's always the first thing you look for. So if you guys are looking at this expression, what is the GCF? Okay, x. So if I pull out x as my GCF, what would be left behind? Awesome. Then make sure you always set equal to 0 because we are solving. Alright, what's in parentheses? The x plus 4. Can you continue factoring that? No, that's it. That's it. So for this question, the only thing you can do is factor the GCF. There's nothing more to do. So now that we're done factoring, how do you guys think that would solve? No, if you distribute, you completely undo what we just did. I finished factoring. What's the next thing you do when you finish factoring to solve? How? Okay. X plus 4 equals 0. I understand that. How many x's do you have up here? So how many solutions do you have? Okay, where's the other one? Nope. I don't care if I'm for the factor. How many factors do I have up here? I have x is one factor, the GCF, and I have x plus 4 is the other factor. If there are two factors, you have two equations to write. It doesn't matter if it's just x, that's fine. That actually makes it easier for you. This one you don't have to solve, it just tells you straight up that x is 0. This one you have to do a little extra work by subtraction to get negative 4. So you guys still have two answers. You have 4 and negative 4. Right? Pro tip. However many expressions you have that have x's in them, however many factors you have with an x, that's how many solutions you will have. So I had two factors with x's. I had the GCF factor and I had the transcendental factor. That's two factors, two solutions. So however many x's you have in your factors, that's how many solutions you'll have. Alright, how would I do this one with factoring? How would I factor that? We took a quiz on this earlier. What do you know about these two numbers? The perfect squares, so you're going to use the square root method. So if I take the square root of both of these, I had x is 5. So then how would I write the factors? X plus 5 and x minus 5 equals 0. We are solving. Alright. So again, you have to remember all the different types of factoring, not just the trinomials or the GCF. You also have to remember the stuff from the second lesson on factoring. You guys will never be asked to solve the perfect cubes. The ones where you had the small one and the long one. You will never be asked to solve that. You need to know how to factor, but you will never be asked to solve that. The ones you will be asked to solve are GCF, trinomial factoring, and the perfect square factoring. Just be aware of that. So I have two factors. So how many solutions will I have? 2. How do I find them? Take both of them and set them equal to 0. I get x equals -5 and +5. Right? So solving by factoring is literally just repeating what we talked about the last two lessons, figure out what kind of factoring it is, make sure it's in standard form, do the factoring, and at the very end, take your factors, set them equal to 0. It's just that one little extra step. Yes? Plus or minus 5? Oh, I don't care. You can either write one x and a comma between them, or write two separate x's. I honestly really don't care. All right, our last method here. This is called the quadratic formula. If you do not know it, it is up here in this corner. If you have it memorized, that is fantastic. But you do not have to have it memorized. It will be provided for you. If I do not provide it for you on accident, just remind me and I'll write it on the board. So basically, this needs to be in standard form as well. So just write this up here so you guys can reference that again. When you guys are working with quadratic formula, it needs to be set up the same way as if you guys were going to factor. The reason why we have a quadratic formula is because some things cannot be factored. If we could factor everything to solve, we would, because it's simpler. But there are some things that simply can't be factored. So in order to solve them, when we can't use factoring, we have to use the quadratic formula. This is kind of like a last-ditch effort kind of thing. Unless I specifically tell you to use the quadratic formula, you shouldn't try to use this unless you can't factor. This is saved for emergencies if you can't factor something. So make sure it's in standard form, and then you're going to identify A, B, and C in your expression. Then all you have to do is plug them in here into this formula and then multiply. That's how we use the quadratic formula. Let's take a look at the first one. Is this written in standard form? It is. Awesome. Perfect. Alright, then what I want you guys to do is tell me what A, B, and C are. A is 3. Okay, so take note of what those are so you can easily plug them in where they're supposed to go. So we're going to go ahead and get started. So for the quadratic formula, x equals negative b, because b is already negative, that's a double negative makes it positive. Negative b plus or minus, and then we have this really long square root. Now what I like to do when I'm plugging into the quadratic formula, I like to do whatever I can mentally. I would do that in my head as I'm plugging things in, just so I don't have to have so much messiness there. So if I'm trying to do b squared, what would negative 9 squared? So I like to go ahead and just write that. So I can take care of some of the work so it's not as much writing. And then minus 4 times a times c. So a is 3 and c is 5. So I got a little bit out of it. There we go. That's all inside of the square root. So then I draw this long fraction bar, because everything that I just wrote is in the numerator, and the denominator is 2 times a. What is a? So multiply that times 0. You can just do little details in your head. If you notice that you can do it in your head, you can just do it right there to avoid writing out a bunch of different steps. Yes? Yeah. Anything you can do quick in your head, feel free to do that. All right, so once you have everything written down, the rest of it is just filtering it down so it's simplified until the very, very end. So next step, I have 9 plus or minus. Let's go ahead and find out what is inside the radical. So this is 4 times 3 times 5. 60? Okay. So what's 81 minus 60? Okay. So inside of the radical is 21. Okay. Now once you guys are here, once the radical over here, you simplify what that number is. The next thing you want to do is see if you can actually simplify the radical itself. Can I simplify the square root of 21? Can I split it into like perfect square any numbers that'll help me simplify? If you can't, that's it. Once you've boiled everything down and you have one number inside of the radical, if you cannot simplify the radical, you are done. I know that one thing that a lot of my students in the past have been tempted to do is to simplify the 9 and the 6. You cannot do that. The only way that you can simplify this fraction is if you have something for all 3 of these that will cancel out. And so that's why you would check to see if you can simplify the radical first. Because if you can and it brings a number out that can cancel with the 9 and the 6, you would do that. But if you cannot simplify the radical, you stop and you're done. Okay? If you want to write that down, you can. If you can't simplify the radical, you're done. All right, what about the next example? Is that written appropriately? Okay, so how would I write it correctly? All right, now this one, don't worry about the negative in the front. We're not trying to factor, so it's okay that it's there. It's fine that it's there. You don't need to pull it out. Now, do you guys see how, if you guys tried to factor this, do you guys understand how it would work? If you pulled out the subtraction or the minus, you'd get negative 8, negative 1. Are there any numbers that multiply to get negative 1 that add to get 8? No. See, that's why you can't factor these. So that's why you have to use the quadratic formula to solve. You can't factor. All right, so what is A? B and C. All right, now just start plugging stuff in. So x is equal to negative b, so negative 8, plus or minus the square root of, what's b squared? 4 minus 4 times a times all over 2 times a. We do 2 times negative 1, negative 2. Negative 2. Does everybody follow where I am? Just plugging stuff in, doing some mental math along the way. Yes? Not done yet. Calm down. This is not my final answer. Alright, so once you've jotted down some numbers, we can simplify from here. So inside of the radical, I have 64, and I have 4 times negative 1 times 1. That makes this negative 4. But I'm subtracting a negative 4. So double negative. So this is really 64 plus 4. Does everybody see that mentally? So it's 64 plus 4. Okay. Now for this one, can I simplify the square root of 68? Yes, I can. Yes, I can. I can divide 68 by a perfect square, I can simplify it. You just need to find the biggest perfect square that is a factor of 68. So I like to go to the side like this and draw these two little arrow thingies. What are two numbers that multiply to get 68 where one of them is a perfect square? This is the process you need to go through when you're simplifying radicals in general. Memorize your calculator. If you can't think about it in your head, start dividing 68 by a bunch of perfect squares until you find the biggest one. Let's start with 4. What's 68 divided by 4? 17. 17 is a prime number, isn't it? So would you be able to keep going, or is 4 it? 4 is it. So I would have 4 times 17. This is really the square root of 4 times the square root of 17 gives us the square root of 68. So then if I write my answer like this, how would I rewrite the radical simplify? 2 root 17. Because the square root of 4 is 2, and the square root of 17 can be simplified, so that's what's left. And I should have written smaller because there's one more line. Hold on. Okay. So again, you always want to check to see if you can simplify the radical. If you can simplify the radical, you do. And then the last thing that you check for, once you simplify the radical, can I cancel or divide something from each one of these three things? What can I divide away from each of these three things? A negative 2. So I would cancel out a negative 2. And then I would have 4 plus or minus negative squared, because if you divide, oh no, wait, hold on. Now I can't remember. I can't remember if you write the negative there, or you don't have to because of the plus or minus. You don't have to because of the plus or minus. When you guys are dividing this number by a negative, it kind of gets swallowed up by the plus or minus. It represents that answer, so you don't have to write an extra minus here. So the negative 8 becomes a 4. This just cancels itself out, and so does the bottom one. So you guys can write over 1 or just leave that blank. If you don't want to write fractions, perfectly fine. But this will be a factor. Yes, great. Alright, so sometimes the quadratic formula can get a little bit longer, it can be up to 2 steps longer. That only happens if you can simplify the radical. So if you can simplify the radical, do so. And then if you can cancel something out of these three things, you won't always be able to do that, but if you can, you would simplify something small for you. Alright. Let's go for our last one here. Is this written appropriately? It is not. How do I fix it? Okay. Once it's in standard form, again, you have the x squared, then the x, then the number, then the equal sign, then 0. Say again? Oh, sorry, I put everything on the other side. I like everything to be positive, so I put it on that side. It won't change your answer. The negatives will cancel out if you do it the other way, but it's usually better to make sure that the x squared is positive. You can do that. Either way, it'll work out. Alright, so I'm here. So we have that A is 3, B is 6, and C is 4. Correct? And again, this is an example where you wouldn't be able to factor, because if you multiply 3 times 4, you get 12. There are no numbers that multiply to get 12 that add to get 6. So again, can't factor, so you have to use quadratic formula. Alright, so I have x equals negative b plus or minus the square root of 4. 36 minus 4 times a times c. 4 times 3 times 4. I write in video times all over what? Alright, let's keep going. So I have negative 6 plus or minus. Now we can simplify inside the radical a little bit more. So we have 4 times 3 times 4. What's this number over here? 48. So it's 36 minus 48. Uh-oh. We're going to have a larger number. So exciting. Alright, so in this one we are going to have imaginary numbers. So again, just like we have over here and here at this step, right here where you're at this point, you need to ask yourself, can I simplify the square root? Can I simplify the radical? Your answer would be yes. Okay. Not only can you change the minus to an I, can I just in general simplify the square root of 12? Can? Just in general, like if it was positive 12. What two numbers would I split the 12 into? Not 6 and 2. 4 and 3. When you guys are doing the split, you want to pick one number that's a perfect square and another number that isn't. So 4 times 3 would be the factorization, the prime factorization that you would want. Not prime factorization, but the factorization. So as negative 6 plus or minus, how would I write the full simplification of this radical? Very nice. We practiced that on the imaginary numbers lesson. So if you need more practice with simplifying negative radicals, go back to that lesson. You should already know how to do that. That's a skill that we've already practiced. So once you're here, again, once you're here, you ask, can I simplify the radical? If the answer is yes, you do that. Then after you do that, you ask yourself, can I cancel something from these three objects, these three numbers? Yes, I can. What is it? 2. Just 2. Just 2. You want to divide by the smallest thing that they all have in common, kind of like the GCF, just cancels itself out. So we're going to divide all of these by 2, so I get negative 3 plus or minus I square root 3. That would be your final answer. Okay, so it does get a little bit sloppy sometimes, but again, when you guys just ask yourself, once you simplify up to here, it should be relatively easy, yes? So all you're doing is multiplication and adding, just that kind of thing. Once you're here, you just simplify a radical, and then if you can cancel something from these three numbers, you do so. So it can be up to 2 steps longer than where we were here. Just make sure you're checking as you're going, checking little boxes as you're going through the process. Questions on that? Okay. Then really briefly, we're done with the solving stuff. But if you guys would like to use your calculator to help you check to see if your answer is correct, I have written out the process you follow here. This is using the TI calculator. You could also use Desmos. If you would like to use Desmos, all you have to do is write the equation in. The equation that you're trying to solve, you would type it in and set it equal to 0. No, sorry. Say y equals, and then you type in the equation. It'll show you a graph, and then wherever it hits the x-axis, just like it shows here, the solutions are the x-intercepts. So in Desmos, you can just graph it, look at the x-intercepts, and those would be the solutions. So you can either use your TI calculator using this process that I've tried to put in as much detail as I can here for you guys to understand. This is what your screen looks like. So you can use your TI calculator to check your answer, or you can use Desmos by graphing and looking at the x-intercepts. So there are 2 different ways you can use technology to check your answers. Feel free to use either or none, whatever you guys would like. The last thing we're going to talk about really quickly, hold on, let's connect to our learning targets really quick. So we've done up to here. How do you guys feel about those? Is everybody okay with the square roots? Alright, everybody okay with factoring? I know quadratic formula is probably the most complicated, so it will take a little bit of getting used to. But again, I mentioned this is a last-ditch effort strategy. You only use this if you can't factor. Most times you can factor or use the square root method. This is only for emergencies if you can't factor. So you probably won't use that often, unless I specifically tell you to use that method. Okay, so the last thing we're going to talk about is how can I determine how many solutions my function will have just by looking at the equation. Okay, so the discriminant looks like this. So the discriminant is part of the quadratic formula. It's the square root of b squared minus 4a. We have a special name for just that little piece of the quadratic formula, and it's called the discriminant. The discriminant is what tells you how many what type of solutions you will have. So it can tell you if you'll have one solution, it'll tell you if you have 2 solutions, it'll tell you whether they're imaginary or real. All of that information comes from the discriminant. It's actually kind of cool. So if your discriminant turns out to be positive, if you guys are doing, hold on, that was get rid of the square root. I shouldn't have included that. The discriminant is just b squared minus 4ac, or you can turn the square root into 1. That was my mistake. You don't actually include the square root, it's just what's inside. That's my fault. The discriminant is just b squared minus 4ac without the square root. So if you guys plug in the numbers and you get that it's positive, you guys will have one real solution. So it could be 2, or 4, or -6, or 2.5. Just one solution that is a real number. If your discriminant turns out to be 0, I put these in different orders last year. Sorry, this one's 2 real, this is 1 real. In the past years, I've done 0, positive, negative, and I forgot that I changed it. That's my fault. I should not change things. Okay, so sorry, if the discriminant is positive, you're going to have 2 real solutions. If the discriminant is 0, you will have 1 real. What do you think happens if your discriminant is negative? That is true, but not true. You'll have no real solutions. However, instead of that, you'll have 2 imaginary. Remember how I taught you guys when we were learning the imaginary numbers? Before you guys knew what imaginary numbers were, you would have to say that there were no solutions because you only knew what real numbers were. Now you guys have no real solutions. Instead, you're going to have 2 imaginary. So you're exactly right, John, that you said that there are no solutions. That means that there's no real solutions, but instead you're going to have 2 imaginary. So in Algebra 2 lingo, instead of saying no real solutions, you would say 2 imaginary. But they essentially mean the same thing. Alright, let's experiment. See if we can figure this out. So our first one here, we have 2x squared plus 4x plus 1. It's written correctly. So I just want to find out how many and what type of solutions this has. I don't want to find out what the solutions are. I just want to know how many and what type. So how do you think I would do that? Plug it into this guy right here. So b is 4. So 4 squared is 16 minus 4 times 2 times 1. Does everybody understand how I got those? I'm taking the a, the b, and the c, and I'm plugging it into the discriminant up here, b squared minus 4ac. Does everybody see that? Okay, so if I do the work, if I do 16 minus 8, get 8. Does that mean I have 8 solutions? No. This is called the discriminant. This number right here is a discriminant. This is a positive number. How many solutions? 2 real. So you're going to find the discriminant first and decide if it's positive, 0, or negative, and then based on that, you're going to use this little chart right here to figure out what the answer is. 16, so I took, this was b right here, so I took the 4 and I plugged it into the discriminant, 4 squared is 16. I'm taking each of these numbers right here, the a, the b, and the c, and I'm plugging it into my formula. Alright, let's see what happens with example b. So I have a, b, and c again. It is slightly different than the one above it. So I'm going to have 16 again, because 4 squared is 16, then 4 times 2 times 2. This time I get 0. If the discriminant is 0, does that mean that there are no solutions? It means that there is one real solution. I know that can be a little bit confusing. You don't want to use the number that you get. This is called the discriminant, and then you have to use this code here, whether it's positive, 0, or negative. Okay, next one. Trick question, sort of. What would my work look like? Why do I have 0 squared at the front? Because there's no b. Remember that b is supposed to be attached to the x term? A is attached to the x squared, b is attached to the x, and c is a number without a variable. I have a and c, but I don't have a b. However, you still need to plug b into the expression, so you use a 0 to stand for b. So what's 0 minus 28? This is a negative number. How many solutions will I have? 2, and what type? Okay. Remember, this is called the discriminant. These numbers right here are the discriminant, and based on what kind of number that is, it tells us how many and what type of solution. All right, what about our last one here? What is B? 1, then 1 squared minus 4, what's A? What's C? So I have 1, this whole thing, this multiplies by 0, just becomes 0. So it's 1 minus 0, which is, so it's a positive 1. I have 2 real solutions. So I apologize for this is another thing you guys need to memorize. If it's a positive number for the discriminant, you will have 2 real numbers. If it's a 0, exactly 0, you have 1 real solution. And if it's a negative number, then you have 2 imaginary. Now, last thing really quickly is this visual. Right? This should be pretty straightforward, right? Remember at the very beginning I said that solutions mean the same thing as zeros, roots, and x-intercepts? So if I ask you to look at these pictures and tell me how many solutions they have and what type, you can do this visually. Take a look at this one. It would be 2 imaginary because it's not touching the x-axis. The x-axis represents real numbers, real solutions. So if it's not even touching the x-axis, it doesn't have real solutions, it's going to have 2 imaginary. Okay? So basically what you're looking for is if it doesn't hit the x-axis, you have 2 imaginary solutions. It's really easy to spot visually. What about this one? 1. So it only hits the x-intercept in 1 spot. So it has 1 real solution. What about this one? 2. So it hits the x-intercept, or sorry, the x-axis in 2 spots. So it has 2 real solutions. What about this one? This one? 2 real. Alright, so what's really cool is that if you guys are trying to figure out how many and what type of solutions you have, and you're not sure how to use the discriminant, well, if the directions on an exam say to use the discriminant, I expect to see this. But if I just out of the blue say, how many solutions does this have? And you would rather graph it than use the discriminant, go ahead. Stick it in your calculator, look at the graph that it makes, how many times it hits the x-axis. So you can use the visual. Unless I specify that I want you to do this process, you can use the graphing. Feel free to choose which one you would like. Yes? No, because your quadratic formula can't hit the x-axis more than twice. You'll either have, these are the only options. 1 real, 2 real, or 2 imaginary. Alright, so I know that was long-winded. I know that was a lot. It was our last lesson. Does anybody have any questions overall? Alright, so the memorization that's involved with this lesson is memorizing the formula for discriminant. You do need to memorize that. You also need to memorize what the rule is for the discriminant, but I will provide the quadratic formula for you, so you don't need to memorize that. Anything else before we wrap up?